Yeah, this is in general, not only for food analysis. As I said before, it's the development of the method. It's a very important point because we don't have only one separation, we have two separations. So the first advice that I can give is to use a narrow bore column in the first dimension to reduce the amount of solvent we transfer into the second dimension. And this is mainly when the solvent from the first dimension and the second dimension, they are not compatible. So, for example, they are immiscible. And so if we reduce the volume, we have less problem. The second point that we must consider that we have to develop the better analysis in the first and the second dimension, and then we can couple the system. The second problem with the comprehensive LC is also related to the very fast analysis we have in the second dimension. And so the second dimension, because it's online comprehensive LC, the second dimension must be very fast. And also, if we use the gradient, that is sometimes a must, we have to recondition the column for the next fraction. So the time that we normally have with the comprehensive LC, that's different for comprehensive GC, is about 1 or 2 minutes. So in this 1 or 2 minutes, we have to also run the chromatography in the second dimension, but also to recondition the column. So if we want to develop a good method in comprehensive LC for food analysis also, we need some very nice stationary phase in the second dimension, not only for the point of peak capacity or resolution, but also for the time that this stationary phase need to be reconditioned to the starting point of the gradient. So this column, we started, for example, in our lab with the monoliths, because they are very fast in recondition. Then we passed to partially porous particle. This is a very good approach, also because due to the very fast recondition. And in the last month also we reduced the time, so we increased the efficiency by using UPLC in the second dimension. So we use a sub-2 micrometer particle, and in this case we use an approach that is using polydispersed particle. But what is very important is that normally we cannot use a totally porous in the second dimension, because otherwise we need a big time to recondition the column.